Now let's study the next important method of integrating, that is called as integration by parts. Let u and v be the functions of x, then integral of u into v with respect to x is given by u into integral of v with respect to x minus integral of du by dx into integral of v with respect to x and whole integrated with respect to x. So basically this method gives us a way to integrate the product of two functions, right? Now let's see a quick proof of this particular statement. Right, now to prove this, we start off by assuming the integral of v dx to be equal to, say, w, right? So therefore, in other words, what it means is dw by dx is nothing but v, isn't it? That is, integral of v is w, so derivative of w is v, right? Now next we consider the derivative of the product uw, that is u into w. Now we know how to differentiate a product, so that is u into dw by dx plus w into du by dx. So therefore that is nothing but u into dw by dx is v, so I write it as v plus, now while writing the second term, let me first write du by dx, and w is nothing but, we can write it as integral of v dx because that is what we had assumed it. So now if you see, the derivative of uw is this particular expression. So it means uw is nothing but the integral of the expression that we have got on the right hand side. So it means that uw is nothing but the integral of uv plus du by dx into integral of v dx, isn't it? Now on left hand side we can rewrite w as nothing but integral of v dx, and on the right hand side we can break the integral. So the first integral is integral of uv plus second integral is integral of du by dx into integral of v dx, and everything integrated with respect to x. So therefore taking the second term on the left hand side, we will get integral of uv dx as u into integral of v minus integral of du by dx times integral of v dx. So that is what is nothing but the statement that we had to prove. Now we must choose the two functions u and v carefully, because if you observe in the expression of this statement of integration by parts, v is the function which is always getting integrated if you see the formula. So that means we must pick up v as that function which is easier to integrate as compared to u, right? So u is relatively difficult function to integrate as compared to v. So therefore if you see, what happens to u is either it remains as it is or it gets differentiated, alright? So therefore we have to use a rule called as Liet rule to choose which function should be considered as u and which should be considered as v. So let us see what that Liet rule means. So it is nothing but a mnemonic, and these 5 letters stand for the 5 different types of functions as shown here. So L stands for logarithmic, I is inverse trigonometric function, A is algebraic function, T is trigonometric function, and E is exponential function. Now if you observe, as we go from left to right, the ease of integration of the function increases. So that means the more on left the function is, easier it is to integrate as compared to the corresponding function on left side, alright? So therefore based on this we decide which should be u and which should be v, right? Now let's see the different cases of the questions in which we can use the integration by parts. First case is two different functions are present in the integrand. So we have to use the Liet rule as we know it. So here is the question. We have to integrate the product of x and sin x. If you see, these are two different types of function, that is x is an algebraic function and sin x is nothing but the trigonometric function. So if you recollect Liet, L-I-A-T-E, the algebraic function comes first and then the trigonometric. So therefore this first function must be considered as u and second function must be considered as v, right? Now as per the rule, we have first function into integral of second function minus integral of derivative of first function, that is derivative of x, into integral of second function, that is sin x, and all of this integrated once again with respect to x. So solving that further, we know that integral of sin is minus cos, so we have it as minus x cos x minus, now derivative of x is 1, so no need to write it, and inside we have once again integral of sin x, so that gives us integral of minus cos x dx, so that is minus x cos x, bringing minus sign outside it becomes plus, and we have to integrate now just cos x. So finally we get minus x cos x plus integral of cos is sin x, so therefore we have sin x plus c. That is the answer, right? So this is how we use the integration by parts using the Liet rule. Now let's see another type. Now sometimes only one function is given to us, so in that case it's not known what is the second function, so we assume the second function as 1. Alright, so this is one example, that is, suppose we have to integrate log x. Now since second function is not visible, what we do is we assume the second function as specifically 1, right? Because you see that it will help us simplify the integral. So that means log x must be the first function u and v must be the second function, because log x stands for logarithmic function and 1 is nothing but an algebraic function, and in the Liet rule L comes first. So solving that, we have log x into integral of 1 minus integral of, inside we have derivative of first function, that is derivative of log x, into integral of second function, and everything integrated at the end with respect to x. Now integral of 1 is x, so let us write it as x log x, right, minus integral of, now derivative of log x is 1 upon x into integral of 1 is x itself. So therefore here x gets cancelled, and in the next line we have x into log x minus, in the second integral we have to integrate just 1, so its integral is x plus c. So that is the final answer. It will be good to remember the integral of log, because it might be needed in some of the advanced examples. So that is x log x minus x plus c.